Okay, our next venture in naming is going to come with polyatomic ions. And we talked about polyatomic ions in the previous chapter, and we saw how to build them, basically. And if you remember, a polyatomic ion is a covalently bonded substance with a charge. And we're going to learn how that actually ionically bonds with a metal to form a brand new compound. Now, before we do that, though, in the last section, one of the things that you were learning was that some compounds require a Roman numeral and other compounds do not. So I want you to take a moment and go through this list, and I want you to write down in your notes the ones that require a Roman numeral. And when I say that, I mean by writing it, they require a Roman numeral in their name. So, some of the ones that you should have written down would be FeCl2, okay? That would be iron 2 chloride, okay? CuF2, that would be copper 2 fluoride. TiO2 would be titanium 4 chloride, but not silver chloride, okay? Not magnesium chloride. But you would for cobalt 3 fluoride, you would not for aluminum oxide, you would not for cadmium chloride, you would not for barium chloride, but for nickel 4 fluoride you would. You would not for zinc oxide, but you would for mercury 2 chloride. And the big thing here is you have to know what elements only have one charge. And you have that colored periodic table, and you can look in the box and you can see if it only has one charge, then it does not require a Roman numeral in the name. So it's very important that you get this statement written down in your notes. Elements that can only have one charge do not require Roman numerals in their name, and it is incorrect to use one. Okay, now that I've kind of reinforced that, we've done Lewis structures in the past, okay? So let's draw the Lewis structure for SO4 2-. That's a polyatomic ion. I have a sulfur that has 6 electrons, and I have 4 oxygens, okay? So basically what I have here is 30 electrons that I have to deal with, because each of these has 6 electrons, and basically 6 times 5 is 30 electrons, okay? So I have 30 electrons to work with, but then this 2- right here means I get 2 more electrons. Okay, so I have a total of 32 electrons. Well, that's kind of nice because 32 is divisible by 8. So what I could do is take sulfur, and I could take its 4 sides, and I could put 1 oxygen up here with its 6 electrons. I could put 1 oxygen over here with its 6 electrons. And one of the things that you'll see is this right here and this right here would be that, excuse me, coordinate covalent bond that we've talked about, where one atom is donating both electrons. Okay, then I could put another oxygen over on this side, and it could share one of its electrons. Then you have 2, 3, 4, 5, 6. And it's short one, but I won't deal with that right now. And then you can have another oxygen over here where it can share one of its electrons, and you go 2, 3, 4, 5, and 6. So if you count all of our electrons right now, we actually have the 30 electrons from the original dot structure, but I get 2 more, okay? So those 2 more come in here, and this is my Lewis structure for the SO4 2 minus. Now, where does it get those 2 electrons? Well, remember, there are elements out there, like magnesium, okay, metal, that likes to give up 2 electrons. Okay, so this magnesium, okay, likes to become a magnesium with a +2 charge. Well, how does it do that? Well, what it does is it gives up its 2 electrons. And when it gives up those 2 electrons, okay, now it has a +2 charge. And guess what? Once it gives up those 2 electrons with its +2 charge, and it has this sulfate with a -2 charge, those 2 are going to become ionically bonded to each other, because this is a metal and this is a polyatomic ion, and they're going to be ionically bonded. So we're going to get a new type of formula, which is going to be MgSO4. Now, our big issue is, okay, how do I name that? Okay, so I'll have to come up with a name. But remember, okay, polyatomic ions were just covalently bonded atoms that have a charge. So we're going to deal with this. And what happens is each polyatomic ion has a certain name. Okay, so this SO4 that we were dealing with, okay, that the name of that group of atoms, this collective group of atoms right here with the 2 minus charge, is sulfate. Okay, now, how am I going to know what all these names are? Well, you have a sheet, okay, and you probably can't read this very well, okay, but you have a sheet that says the polyatomic ion chart. If I would like you to go ahead and dig that out right now. It should be one of the first pages in your packet. And if you look at that, that has the name of all the polyatomic ions on it. This is something you do not have to memorize. You get to use this on the test. Right? So it's not something that you're going to go through, but you do need to learn how to use it. Okay? So this SO4 is sulfate. And here's the key. You see those pretty blue letters there. Okay? When you have an ATE ending, that is the indication that you have a polyatomic ion present. So an ATE ending is a polyatomic ion, as opposed to the ending that we've had up to this point, which has been IDE. Okay? And there you go. If I have an IDE ending, that was just sulfur, okay, with the S2 minus, and we call that sulfide. So now you have sulfide and sulfate. And all polyatomic ions, okay, are going to have this ATE ending. So here's another one, carbonate. Okay, I'm going to throw this down here, and nitrate. Okay, and I'm just going to go through here. Chlorate, chromate, phosphate, borate. Okay, these are all different polyatomic ions. And notice that they all have an ATE ending. Okay, I'm going to point out another little thing. Notice that this is carbonate, and it has carbon in it, and oxygen. Nitrate has nitrogen and oxygen. Chlorate has chlorine and oxygen. Chromate, okay? All these polyatomic ions have oxygen in them. Now, not all polyatomic ions have oxygen, but ones that end in ATE do have oxygen, and the name is basically the other element that it's with. Phosphate, phosphorus, borate, borate. Okay, boron, excuse me, okay? And some other little things to note, okay, and you need to include this in your notes. The ATE ending does not indicate the charge of the ion. Okay, one of the things that you'll notice here is this is a -2 charge, this is a -1 charge, -1, -2, -3. Okay, all those charges are not indicated by the ATE ending. The ATE ending just is an indicator that you have a polyatomic ion. and that polyatomic ion contains oxygen. So one of your big things is you're just going to have to learn these, okay? And there are some ones to memorize as we go through, okay? So sulfate is a pretty popular one, okay? But now I got another issue for you. There's SO4, okay? And there's SO3 2 minus, okay? This SO3 2 minus is called sulfite. Okay, notice we have a new ending. Okay, I'm going to give you another one. We have phosphate, okay, which is PO4 3 minus, and then we have phosphite, which is PO3 3 minus. Okay, so I have another ending here, this ITE ending. Okay, and as you look at that, what do you notice about phosphate versus phosphite and sulfate versus sulfite? And hopefully circling those numbers of oxygens helped you indicate that. And what you should see is the ITE ending is a lower number of oxygen atoms. Okay? So if I have NO3 1 minus, the name of that is nitrate. Okay, if I have NO2 1 minus, what would the name of that be? And hopefully you're saying nitrite, okay? And I know I'm throwing a lot at you here real fast, but okay, these are all names of polyatomic ions. And again, I'm going to go back to the fact that you have this polyatomic ion sheet, okay? In fact, right here, you see sulfate and sulfite. Let me see if I can find another one real quick here. There's lots of them on here. I just got to find them. Here's the nitrate and nitrite. Here is the phosphate and the phosphite. So they're on here. You'll just have to become familiar with them. Okay. So right now you basically have three endings that you really need to keep track of, and it's important to keep track of these. Okay. You have an ATE ending, and I want to see this in your notebook. This page, everything I write here should be in your notebook. You have this ATE ending, okay, which if I have an SO4 2 minus, that's a sulfate. Okay. You have this ITE ending, so that would be SO3 2 minus. It's a lower number of oxygens. That's a sulfite. And then you have this IDE ending, which would be S2 minus, and that would be just a sulfide. So these naming systems, okay, are going to tell you a lot, and it's just, you got to become familiar with them. Okay, just to give you another quick example, if I have PO4 3 minus, that's phosphate. Phosphate. If I have PO3 3 minus, that's phosphite. Okay, and if I have P 3 minus, that's phosphide. Okay, so again, we won't change the name of the previous element. These are endings of negative ions. Okay, so we're keeping that in mind. An anion is a negative ion that we're talking about here. So these are the negative ions. I'm going to give you one last one. I'm going to give you the three substances, and I want you to name them. So go ahead and name what you believe those, the name of those should be. First one is nitrate, nitrite, nitride. Okay? 8, ite, ide. So, how does all this work then with naming and writing formulas? Okay, first of all, there's nothing new. Okay, the total charge of the compound still has to be 0, and you just name the polyatomic ions with their name. Okay, so nothing real special. So here I have 2 polyatomic ions. Okay, the first thing I need to do is write the correct formula. Okay, well, this is a +1, this is a -1, so I'm still trying to get to a charge of 0, so my formula is KVO3. Okay, so none of that's changed. That's no different than saying I have +1 and -1 Cl, so that's NaCl. This polyatomic ion is a group, okay, so we keep it together. Okay, now, what you do is you go to your polyatomic ion chart, and one of the things that the way this polyatomic chart is put together is all the ions with a -1 charge are in one group. All the ions with a -2 charge, -3, -4, -5. And you notice you get less and less of those as you go up. And then notice we have one measly positive polyatomic ion. Okay? So what you do is, we know we had VO, okay, and we come down here and we find its name, vanadate. Okay? Well, if I want to name this, okay, this is still potassium. And then this is vanadate. So the name of this is potassium vanadate. Okay? So naming these, you just use the polyatomic ion name. Okay, here's another one. Okay, first of all, excuse me, I want to get the formula of this. And I have a +2 and a -2. So how do you suppose we'll just put these together? Okay, no different than if I had a +2 Mg and a -2O, I would just put those together as MgO. Well, if I have a +2 Cu and a -2 CO3, I just put them together as CuCO3. Okay? So now, I know this is copper, but I also know copper can have more than one charge, so I'm going to call this first one copper 2, because I have to be specific. And then I go to my polyatomic ion sheet and I say, okay, I have a -2 charge. Okay, there's my -2 charge, and it's called carbonate. So this is copper 2. Oopsie, spelling issue. Copper 2 carbonate. Or you could go the old system. It could also be called cupric carbonate. So it has 2 names. Okay, let's try another one. See if you can write the formula of that. And hopefully you're just writing KOH. Okay, now I know potassium, K is potassium, so I write potassium. And I know potassium only has 1 charge, so I don't call it potassium 1. Okay, then I go to the fact that, okay, that OH was a -1 charge, so I come to my -1 charge group here, and I try to find that OH. And this is going to be the trick for you at first. You're not going to know all the names of these, so you got to go find them. Okay, so down here I have that OH, it's hydroxide. So this is potassium hydroxide. Okay, now I wanted to point this out because you notice I don't have the ATE ending here. I have an IDE ending. First rule of chemistry, there's always exceptions to the rules. Okay, go ahead and write the formula of that, and then write the name for me. Okay, so that is the formula. And I know Li is lithium. So what's this MnO4? Well, I gotta go to my chart. I gotta find an MnO4. All right, and one thing you'll notice is that these are in alphabetical order. So MnO4, down in the M's. MnO4, way down here. Permanganate. So, the name of this is lithium permanganate. Okay, so these are some fairly simple polyatomic ions. Now we're going to get into a little bit more complex polyatomic ions. Okay, now, everything to this point has been even charge. So I've just needed one metal and one polyatomic ion. But if I have an odd charge where I have a +3 Fe and a -1 NO, okay, in order to make this balance, okay, I am going to need 3 of these NOs. Okay, because if I take all 3 of those NOs, each one of those adds up to be -3. That matches my +3, so I get my 0 charge that I always want. Okay, but then how do I write this in a formula? Do I write Fe NO3 NO3 NO3? No, we wouldn't do that. That would be very redundant. Okay, so how do I show that I have 3 NO3s? Well, the way you do that is you put these polyatomic ions in parentheses. Okay, and notice I am putting that whole thing in parentheses. So the NO3 is what is in parentheses. And then I have 3 of them. Okay, 1, 2, 3. And this then, right here, is my formula. Now, how would I name that? Well, I have iron. Okay, well, iron is iron. But as I look on my periodic table, I see that iron has multiple charges. Iron can be a +2 or a +3. So I have to indicate that this is the iron 3 version. And then I have to look up this NO3, which is nitrate. So the name of that is iron 3 nitrate. Or, I just have that down there, you could call this ferric nitrate. Okay, so when you have charges that don't match, okay, you're going to have multiples of one thing or the other. Okay, and it doesn't matter what it is. Here's another example. I have a lithium that's a +1 and a carbonate, which is a -2. So I'm going to need more than just one of those. I'm going to need 2 of them. Okay? And again, I would not write this as LiCO3. Okay? That just wouldn't make sense. So I write this as Li sub 2, because that little 2 means I have 2 Li's, CO3. And lithium is one of our elements that does not require a Roman numeral. So this would just be lithium carbonate. Look at another one. Getting more complex as we go, but why don't you see if you can write the formula of this? Now, a few things here. That old crossover method that you've done in the past when I had Al +3 and O -2, and I took in this crossover and I brought that down there, and I took this and I brought that down there, and I could write Al2O3. That still works with polyatomic ions. Okay? This charge can come over here. This charge can come down here. The only thing is, when you do that, I write Al2. Okay? I do not want to write SO4 3 like this. Okay? You need to put parentheses. So I need SO4 3. Okay? So that whole crossover method still works. But just dealing with this, okay, I have 2 aluminums that are +3, and I have 1, 2, oopsie, 3 SO4s that are 2-. Okay? And so this formula right here indicates that that's what I have. I have 2 aluminums, and I have 3 SO4s. And this charge here is +6, and this charge is -6. Okay, so now, how would I name that? Well, aluminum is just aluminum. Aluminum. And SO4 is sulfate. So the name is aluminum sulfate. Oh, I think I'm done. Thought I had one more on that. Okay. Guess I had one more that I wrote down there myself. Okay, so this is our polyatomic ion naming system, and your assignment then right now is to do the polyatomic naming worksheet. Okay, so that should be where you go.